All right, so this tutorial is going to cover creating a number of different scripts in Grasshopper that we can use for utilities and organic modeling in Rhino. One of the fundamental scripts that I've used, or Grasshopper definitions, I should say, is one that subdivides a surface with isocurves. Because from here, there's a lot of surface manipulation that you can do. But this is kind of a very simple, primitive way to generate curves on any surface that you can then instantiate other geometry and other perforations for a panel and things like that. But all of this starts with this simple script. So we'll go over this. I'm also going to introduce some other organic geometries that Grasshopper has, some other tools and components that are useful in modeling anything organic or biology inspired. So we'll start with some components. I'm going to disable this for now and delete this. So to start off, if you go, so in Grasshopper, you can go to the different tabs. You'll notice under Mesh, there's a series of components up here that deal with how to work with points in different ways. So basically, a scattering of different points can generate different patterns. So one of the most common patterns that you'll see in Grasshopper is the Voronoi pattern. This is where a lot of designers will start out when experimenting with Grasshopper because of its kind of organic nature. This is the pattern that you see in dragonfly wings and other cellular structures. And so when you drop in this component, and again, it's Voronoi here under triangulation under the Mesh tab. And you can also double click on the canvas and type Voronoi. There's a 2D and a 3D Voronoi component. We're going to start with the 2D one. And anytime you have a new component, mouse over the first few letters and it'll tell you what it's looking for. And so the first thing it's looking for are points. So we want to give it some points. And I could go into Rhino and type point, spacebar to repeat the command, and just create a series of points like this, all along the C-plane. And I could then assign those points. So to do that, I'm going to double click on the canvas and type point so that I can pull in that parameter. So drag that in. And then I'm going to right click on that and say set multiple points. Okay, so this is going to create the bridge between Rhino and Grasshopper. So I hit enter. It's going to create a link between this geometry that's physically in the Rhino space and these components that are then modifying it. So I can close Grasshopper and that goes away. I can type Grasshopper and it comes back. Okay, so this is one of the kind of primitive components that you'll see in Grasshopper that most designers start with. And you'll notice the beauty of this kind of real-time coding scenario is I can move these points and you'll see that the Voronoi pattern is updating as a result. And so the Voronoi logic is pretty simple. It creates a boundary around each point, and then there's some boundary around the whole kind of set of points. And it's going to create basically a perimeter that averages the center between each point to create the pattern. So again, this is the pattern that you'll see in a lot of different wings of butterflies and dragonflies and other things, other animals. You can also see this in plant cells and things like that. But these points we just added manually, right? So I'm going to delete these. what I want to do is have Grasshopper generate random points that I then feed into this Voronoi component. So under vector, you'll see the grid drop down, and there's this command populate 2D. What this is going to do is it's going to populate any two-dimensional plane with random points. So I can click on that, and just by default you'll see that it's creating a plane with random points on it. Okay, and so I can change the parameters and tell it the size of the plane that I want it to work on and the number of points. And I'm going to move this over. So again, mousing over this, so if I mouse over R, it's asking for a rectangle, and that rectangle is going to be the exterior boundary of this shape. It's also asking for the number of points, and by default it's set to 100, so you can see that when you mouse over it. And then a random seed. So there is no such thing in computation as true randomness, so it uses seeds. So there's pseudo random code that it uses to populate this. So changing the seed will give you different pseudo random organizations on here. And then an optional pre-existing population of points. We're not going to use that one, but if I give this a rectangle, so I'm going to type rectangle in Rhino and start at 0, hitting 0, enter, and just creating a large rectangle. I'm going to select that. And in Grasshopper, I could either type rectangle and bring that in, or I believe curve will work. So I can select the rectangle, right-click this, and say set one curve, and it's going to populate that rectangle with this population of pseudo-random points. And I can change the number of points by inputting a slider. So all these parameters, whether it's a point, curve, surface, brep, all of these are found under params and geometry. To give it a number input that you can control with a slider, you can bring in this number slider here. So I'm going to click on that, and you can also get that by just double clicking on the canvas and typing in some number, say 4.5, and then clicking on it, and now I have a number slider, and it'll create the kind of bottom and top boundaries of that domain by default, but then you can then right click this and say edit and change the upper and lower limits of it by changing the minimum and maximum number. So I want to set the maximum to 500. And this you can change to integers because we don't want decimals in this. I just want to give it a number of points, so 300 points, for example. So I'm going to set that to n, so it won't round any decimal points, and then hit OK. So now I have numbers in my slider from 0 to 500, so I could set this to whatever I want, and I can plug that into this n. And again, if you ever wonder what it's looking for, just mouse over it and it'll tell you. So it's looking for a number of points to add. So I'm inputting 263 points. I can change that number, bring it up or down as needed. And so I'm populating this flat plane, or this rectangle, with points. So with the points in this component, I can then plug those in. I could either plug them in here, or I could plug them directly into our Voronoi component. And so you see the pattern that it's creating on that surface. So, again, this is a cell pattern you'll see in nature, not just in animals, but in plants and other organisms. And so it's giving us this. And so when we're happy with it, we can middle mouse click and click on this bake button. And then closing Grasshopper, we can see that each of these is its own cell. All right, so it just baked all of these. And when we bake something, it's a way of taking it from Grasshopper into Rhino. So now we can work on this in Rhino. If I wanted to manipulate these, I could. I could select a bunch of these and type extrude, for example. Set an extrusion height. All right, so now this is kind of workable geometry in Rhino. Hitting Control Z. Hit Control Z again. And then typing Grasshopper, hitting Enter, will bring this back up. So you can see the difference between manipulating something in Grasshopper, which, by the way, changing the number of these is going to change the cells as well. So that's the beauty of Grasshopper. Instead of typing in code and then hitting run and not knowing if it's going to work or not, in Grasshopper you can see these changes happen in real time. So you can play with the script or what they call a Grasshopper definition and then see those changes happen in 3D in real time. All right, so that's the kind of Voronoi way of working in Voronoi pattern. I'm going to deactivate this so it doesn't show up and it's not being calculated. So I'm going to select the whole thing, middle mouse click out here, and then say disable. So it's going to stop calculating this, just like I did up here for the previous one. But we'll cover that one in a sec. First, going back to these mesh options, we talked about Voronoi. There's other connection types too for creating different cell types. So there's this one, Delaunay edges. So this one is also asking for points, but what it's going to do, instead of creating cells around the points, it's going to connect the points themselves, connect the dots. So I can use the same kind of starting ingredients as I did before, where I start with a curve and then populate it two-dimensionally. So I can select these, Control C, Control V, move this down, connect these points into that. And I want to activate these. So I'm going to select them, right click, and say enable. And so you'll notice that it's grabbing the same points that we used earlier. And again, I can increase the number of points and decrease. And it's going to generate a connectivity diagram. So instead of cells formed with each point kind of creating the average, here we have points that are being connected to form this network. And again, it's using the same curve that we drew earlier, which I could manipulate in Rhino. So if I wanted to take this and manipulate it, I could play with that and watch it update in real time. And then if you want to hide something, let's say I want to hide this boundary, I can select these, or hide the points. I can select these, right click, and say preview off. So this is different from disabling. Disabling stops calculating it so that now this turns orange because it can't be, this isn't calculating. Disabling turns it off, right? But I want these enabled. I just want to hide it. So I'm going to select these, right click, preview off, and so it hides it from view, but it still uses this to calculate in the entire equation. And you'll notice I'm working from left to right. So this is kind of a way that Grasshopper works. Instead of reading code, it's creating components that you connect. These are like batteries that you're connecting with wires, and then it reads the script from left to right. So if I wanted to keep manipulating this, I would add things onto this connectivity diagram, which you see, is being output here. These are curves and edges that I could then use. So if I double click and type curve, actually that's not curve, these are the curves. I can then bake this, close Grasshopper, and you'll see that all of those lines are now in Grasshopper that I can work with. So for example, if I wanted to pipe all of these and create cylinders around each one, I could double click and type pipe. And pipe is looking for curves, so I can plug those in. It's looking for a radius, so I could type in 1.2 to give us numbers in that range, and then I can change this and affect the thickness of that geometry. These I can then bake, so if I'm happy with this, maybe this is a structure I'm designing, I can middle mouse click, bake, and then bring that into Rhino. There's ways that you can group these objects in Grasshopper so that when you bake them, they're not going to be individual pipes. Type in Grasshopper again. I can double click and type group. Connect that. And then I'm going to flatten it. So I have to flatten the incoming information so that it groups all of them together. So I'm going to right click, flatten. I'm not going to go into data organization. That's a more advanced topic, grouping and flattening and grafting. But I just wanted to show that these could be grouped, middle mouse click and bake. Now this is all one thing when you bring it into Rhino, but you can still select it and type ungroup in Rhino, and now these are individual components. Okay, and so you'll notice that now we're creating content here that should be saved. So I'm going to save this, and this is the name of the project, and you'll notice when you open a new Rhino file, you're going to have to open that Grasshopper script or that Grasshopper component, Grasshopper definition. You're going to have to open that separately. Okay, so type in Grasshopper, brings us back. And again, I can select this, middle mouse click, and disable it. Just to highlight a few other of these. So there's Delaunay Mesh. So instead of creating a network of curves, this can actually create a mesh. So this will take points and a plane, similar to what we did before. So I can select this, Control-C, Control-V, use the pseudo-random points. Selecting this, right-click, Enable, and you'll see that it's generating something. And if I turn this on, it's actually generating a mesh geometry or a mesh surface based on that. So when I bake this, I now have a mesh based on those points. Each point is now the vertex of this mesh, which I can select and then type points on. So if I wanted to manipulate the vertices of that mesh, I could do that. So a mesh is a 3D geometry that's a connection of points forming triangles through each of the edges in that mesh. Okay, so there's a whole world of mesh modeling. Maya is great for that. Rhino can do mesh modeling. There's a whole tab of mesh tools. If you look up here, these are all tools for working with meshes. But Rhino really isn't designed for that. Rhino is a NURBS modeler, so it's best for working with surfaces and complex curvature that is derived from calculus. So it's a different way of modeling, but in Rhino it's a little more accurate to do surface modeling with B-reps and polysurfaces and things. So going back to Grasshopper, so that's the Delaunay Mesh. So again, I'm just populating this with random points, but you could conceivably create your own points and connect them to form this. Let's do a 3D Voronoi. So I'm going to select this, disable it. If we click on Voronoi 3D, drop that in, it's also looking for points. So what I'm going to do, instead of giving it the two-dimensional plane of points that we gave it here, I'm going to give it a volume of points. So to do that, I can go to Vector. Under the grid, you'll see Populate 3D. Okay, so this will populate a 3D volume with points. So you'll notice this is not just two-dimensional. Each of these points exists in space. So it's asking for a box. So before it asked for a rectangle, now it's asking for a box because it has to be volumetric and three-dimensional. So I'm going to double click and just give this geometry, which is a kind of umbrella input. So in Rhino, I'm going to type box, and we'll do something like this. So with this box shape, I can bring this into Grasshopper by selecting it, right-clicking on the component, and saying Set One Geometry. All right, and I'm going to hide this for the sake of clarity so I can see inside. And again, I hide it by selecting it, or actually in Rhino, I just selected it and typed hide. But if you want to hide it here, I can select it, right-click, and say Preview Off. So now I just have those points in 3D. I can then take those points, then plug them into this 3D Voronoi, and you'll see that it gives me a volumetric Voronoi diagram. So it has all of the cells and Boolean values, so true and false values that are being input here. Okay, so if I bake this, you'll see that each of these is a three-dimensional chunk of that Voronoi diagram. And I can also, if I go into ghosted, you'll see into the depth of it a little better. All right, so for those of you who are modeling anything that's biology inspired and you want to take a look at these simple scripts, this is the way to get started in Grasshopper to do so.